Now let's graph rational algebraic fraction. Particularly, we'll start with y equal 1 over x, f of x. Right. Well, there is an asymptote at x equals 0 because the domain is R minus the element 0 for which we cannot calculate f of x. So clearly there is an asymptote at R equals 0. I'll put that as a blue line. There you go. That's the asymptote x equals 0. So asymptote, it's a line that the function approaches but never touch. Maybe I'll write that here. Right. Okay. Let's pick a few points. So at x equal 1, that's equal to 1. So therefore, we're just going to have this point. At x equal minus 1, that's equal to minus 1. So, yep, that's this point. At x equal 2, that's equal to 1/2 of this point. At x equal 1/2, that's equal to 2, so that's here. At x equal to 3, that's 1/3, so that's here. X equal to 1/3, that's 3, so that's here. So I can draw the x side. Right, and then the function is f is odd, so therefore we can basically, it means that the graph is symmetrical with regard to the origin. So okay, so it's easy, we can just it's gonna look like that. Right, and what we can see is that the limit when x tends toward, well, plus or minus infinity of f of x is equal to 0, so that means that y equals 0 is an asymptote. Right, which we can show in blue. Here we go, so that's y equals 0. And yes. Okay, so knowing this graph, we'll just try to deviate a bit using other graphs. So for example, y equal 1 over x minus 2. Well, that's going to be exactly the same, except that we cannot calculate it for x equal 2, so x equal 2 is an asymptote, and basically it's going to look like that. So sorry, this is the x-axis, this is the y-axis, this is the origin, and then same for that side, it's going to look like that. Very bad, but you understand, and this is certainly not touching the line here. Okay. So in that case, two asymptotes again, which are y equals 0 and x equal 2. Let's do a final one. If we do y equal x plus 1 over x. Right. So the domain is r minus the element 0, for which we cannot calculate y. So that means that x equals 0 is an asymptote. What else? Well, the limit when x, or actually instead of saying that, when x is very large or tends towards, so basically plus infinity, or tend towards minus infinity, so either very large or very small, then f of x is pretty much the same than x, because 1 over x is negligible. So that means that f of x being approximately equal to x, that means that y, so therefore y equal x is an asymptote. Okay, so let's graph that. So we said x equals 0 is an asymptote. So let's write it in red, this one. And then there is y equal x, which is y equal x, and x equals 0. So they are both asymptote. Okay, so where now we can pick a value, for example, for x equal 1, that gives us for x equal 1, that gives us 1 plus 1 over 1, which is 2. So it's gonna, the point is gonna be here. For x equal minus 1, that's gonna be minus 1, minus 1, minus 2. Yes, well, actually, we could have seen that because the function is odd, as f of minus x is equal to minus x plus 1 over minus x, which is equal to minus f of x, so f is odd. So therefore symmetrical with O. Okay. Now, so they must, it's coming from there, it's coming from there, and then, yeah, and same for this one, coming from there, coming from there. So there must be a maximum, a local maximum here, somewhere, and a local minimum here. Okay, what are these minimums? We need to find the derivative. F prime of x is equal to 1 minus 1 over x squared, which is the same than x squared minus 1. So f prime of x equals 0 when x is equal to plus or minus 1. So there are two extremums. So at actually we calculated those already. So okay, so that must be here at x equal 1 there is an horizontal tangent, at x equal minus 1 there is a horizontal tangent too, so it's actually looks like that. Here you go.